So real quick high level of the code that I've got up here. We have 5 files, an index HTML. You'll notice that that is then calling in a main, a callback, a promise, and an async-await JavaScript file. So we're going to look at that main file real quick. I'm going to come back to that one. So at the bottom of main.js, I have a bunch of functions that are convenience functions. We're going to be calling them, but they're not particularly relevant to the actual topic that we're covering. At the very top, I have this code up here. So this is an example of a very, very basic callback. For those folks who are looking for a job, who wants to talk about what a callback is in general?
Not looking anymore.
Is that congratulations?
No.
No.
It's a function that calls itself.
It calls what?
Itself.
Okay. Yeah, makes sense. So in here, what are the callback functions? Up front?
In your calculate, it's requiring a callback, and then it's sending it in the console log. So it's firing on line 7.
Firing on line 7. Okay, not quite.
Sum and diff are the callbacks?
Sum and diff are the callbacks. So in our calculate function, we pass in 3 parameters. One of them is named callback. The other 2 are A and B. When we actually call it, you can see I'm calling calculate with either sum or diff. And those are the functions that we've got defined up here. And so when we get to line 6, we actually run either the sum or the diff function. So if I run that code, save, run, why am I not running? Oh, because, okay, it's been a long day. So up here in the console output, you can see that we've got a function, either the sum or the diff, the values that are going in, and then the value that it actually equals. So this is our console log. We're passing in the function sum or the function diff, and then we print out the string with our A, B, and the result, either the A plus B or the A minus B. So anybody who isn't even at the point of looking for a job, who's here that's not at the point of looking for a job yet? Everybody's looking for a job. Excellent. Okay. So for those of you who are looking for a job, does this code make sense? Because this is about as simple as it gets for this presentation.
A quick question. So you're passing sum and diff to kind of a function pointer, is that right? Equivalent of a function pointer?
Yes. Yes.
Same vein, if you will. You know.
Yeah. It's not typically referred to like that in the JavaScript realm, but yes.
That's really what you're in the sense that you're doing.
Yes.
Yeah. Okay.
Yep. Any other questions?
And the reason you would do that is because you need to pass in a function to be computed.
Exactly.
Okay.
Exactly. A function is just an object in the JavaScript realm, and so you can pass it like you can pass any other object. So yes. So any other questions about just callbacks in general? Awesome. Okay. So we're done with that. So we're going to look at 3 different ways that we can handle asynchronous JavaScript. So again, for those of you who are on the job hunt, who wants to tackle what asynchronous JavaScript is?
Asynchronous JavaScript is like JavaScript that calls, like, it will usually make a call to something and then it'll get it later. And so like synchronous means it runs all like from top to bottom, but asynchronous means that there's going to be like stuff that's going to take different amounts of time.
Awesome. Any questions on that at a theoretical level? Okay. So the first example that we're going to look at is callback. Yeah.
Go back here. The callback
Just a generic callback. Yeah.
How is a callback different than a promise?
That is a really good question, and ask me when we get to when we finish up the promise example. Okay. And I will, before I go any further, say that the callback example is using callbacks to handle asynchronous JavaScript. The promise example still uses callbacks. The async-await example still uses callbacks and promises. So there's kind of an evolution here. OK, so for the callback example and the async-await example, we're using a pizza ordering. We got a table with 3 people that are ordering pizza. So there's a probability of whether they will actually get their pizza cooked properly in the kitchen or not, whether it falls on the floor before they can bring it out and serve it. Got some convenience functions up in main that are handling that. The important thing for us is the function from line 3 to 25, at least initially. So this function is taking in a string, which is our customer's name, and it is taking in that callback function. And we're going to look at the callback function in a little bit. We are using, for all 3 of these examples, a set timeout to simulate that asynchronous response time. So you would not normally have a set timeout in your function. You're actually doing something in the function that's taking time. One of the other convenience functions is this pizza making event, and that's actually just determining whether the pizza was made successfully or not at this particular time. So pizza has been made is a Boolean value. We're going to log out the value of whether that customer's pizza has been made or not. If it's been made, we are going to call that callback function, whatever that function is, and we're going to send it this object. And this object has 2 key value pairs, a status and a message. And you'll notice that they are different. We've got a success status message, and we've got a failure status message. And then this lag down here goes with our set timeout. So again, you would not normally have something like this in your code. So does everybody mostly understand what this function is doing?
Just to clarify, that just returns Boolean?
Correct. Yep. OK, so we're going to look at the first incarnation of using this. And this is going to be, we have a single customer. And so this single customer, I do have a couple other convenience functions in here, our order placed and our order served. Those are going to give us some timing, which will make sense toward the latter examples. But we call our make classic pizza function. Alice is our customer. And then this is the callback function that we're sending. Okay? So this callback function itself takes the result that we got. So this object right up here. And if the status of that result is success, then we're going to assign that result object, the entire object, to Alice Pizza Made. We're going to log out the message from Alice Pizza Made, and we're going to stop our timer, that order served for single. If something happens to Alice's pizza, we're going to handle it with this else down here that has a convenience function called oops that takes the message in. And then we call the function. So any questions before I run it? Yeah, maybe. That good? OK. So here we go. Order was placed. We got a lag on there, so it took a little over 1 second. Alice's pizza was made. So we have, just following this out, the first message that we see is this console log from line 9. So this is inside of our make classic pizza. It's the one that has the Boolean value, which should make it a little bit easier. And then our second console log message is the one from our serve table single customer. So we have generated the pizza up here. We've returned, we've made the callback call, which has in turn console logged out the message from that, and it's also stopped our timer with the order served. Does that mostly make sense? Everybody kind of follow that logic? Excellent. Okay, so now we're going to make this a little more complex.
So how is min pizza lag and max pizza lag calculated?
Those are in the convenience functions in main. They're not relevant to the example at hand. Although feel free to go explore them. And I will tell you that I kept the pizza lags, I think between 1 second and 2 seconds. And the second example we're going to look at is cleaning a room. And that one, it's like a half a second to a second and a half or something like that. So they're slightly different just because I'm trying to demonstrate a couple different things. Yes. Yep. It's actually already up in Slack if you want to hit it. Okay. So now that was with a single callback. Actually, before I do that, so that was for a single callback. So what happens if you are trying to do something and wait for the results on that, and then based on the results of that, you're going to make another call, and based on the results of that, you're going to make another call. Callback hell. Okay. So the next example, we're going to look at Alice and Bobby and Charlie. I'll go to a pizza joint, but it has a really tiny oven, so it can only make one pizza at a time. So here is our one pizza at a time with 3 customers. What's the first thing you notice? Anybody? Lots of indentation. Anything else? Yeah, nested statements.
Like there's no, like the main function is not taking like customer and callback.
Yeah, it actually is. So quite literally, these are nested. So you'll see there's our first make classic pizza, there's our second, and there's our third. You'll notice that I also had to bump out, if I want to console log these, I had to bump out these variables because otherwise we end up with some scoping problems. So I had to break that out. You'll notice that up here, I just worked with result. I didn't have to get fancy. But down here, I didn't technically have to do Alice result and Bobby result and Charlie result, but it makes life a whole lot easier to read. I would not want to maintain it even less than I already want to maintain this if they were all 3 result. And I now also have to have these 3 else's down here, which, considering they're all calling the same function, seems kind of silly. So let's go ahead and give that a run and let that do its things. There's our first return, there's our second return, there's our third return, and all the pizzas were made successfully. And took a little over 4 seconds to make all those calls. Any questions? Is this old hat for all of y'all? Or are y'all just trying to digest it? Y'all just too tired to care? What's that?
No response.
No response, okay. This is the long division, yes.
So this is the old way of doing it.
This is the old way of doing it.
This is not standard current, like 2019.
I would not do this unless I had to at this point. Yep. Yeah, no. Yes, I do. So order place is right up here. Yep.
Could you show me that definition?
The actual order place function? Yeah, it's actually super simple. If I can find it. There it is. So order placed is literally, the key part of it is this console time. And then the order served, the key part is this time end, which does the calculations for us. They're over in main, because I use them a couple of times. And I didn't want them cluttering up the example. Yeah, so this is the old way. I do want to go ahead and show you one more example with this. So I would not, unless I absolutely had to, I would not go back to this. And for the most part, there's no reason to go back to this. However, you may have to maintain code that already has it, and so you need to recognize it and that kind of thing. Now, if we wanted to make all 3 calls at the same time, but not do anything until all 3 calls have been done, I now have to set these variables out front. I need an additional function up here, which is actually going to do the comparisons. So I need to make sure that these now have definitions. I need to find out if they all have success or if we've had any failures. And that's the only way I know how to call the order served. But it is a little bit easier down here for these functions because I don't have to nest all of the calls. So there is that upshot. So if I save that and I run this puppy, of course, one of the differences is Bobby's pizza is done before Alice's in this example. But otherwise, it runs a whole lot faster. You'll notice that that was under 2 seconds as opposed to over 4 seconds before. So if you don't need to wait on each one of them, running them all consecutively will speed things up. Any questions? Correct. It's not. Basically, it's kind of like the waiter coming into the kitchen, and there are multiple cooks. And here you do this order, and here you do this order, and here you do it, and let me know when you're done. Call me back when you're done. Right.
So going back to when dealing with legacy code such as this, at what point do you decide this is worth switching to promises or async versus?
Great question. It needs to be in the context of whatever the current project is, what the constraints of the current project are, what your current team is able to support. At this point, I am very lucky to be on a greenfield project. If I had to pick up any project now, I would be arguing very strongly to convert it over unless there was a compelling reason not to. I saw a hand go up.
When each of those callbacks gets called in, were you saying that a thread gets spawned? Or?
Yes. Yeah. We talk about JavaScript being single-threaded. You are in control of a thread, but that thread can spin up other processes when it needs to.
Well, it's more like you're running a process, and then
and
then under that you're going to have threads.
Yep.
Okay.
Yep. Any other questions, comments? Nope. Okay. So it should actually get a whole lot easier from here. Should. Okay. So who wants to take a stab? Actually, I'm going to bounce back over here. For those looking for a job, who wants to take a stab at what a promise is in general, high level? Anybody?
It's a special function that you declare with a resolve or a error. And so you set it up to do some things, and when it's done, you either resolve with the results or the error, and then you call it from your, from another place or from the same place, doesn't really matter. And then from the place that calls it, you can assign it to do something after it's been resolved. So it'll just call and wait until it's been finished. And then
Perfect. Does that make sense to everybody at a high level? I'll take that as the silence is a yes. Okay. So this example, we've moved out of the pizza joint and into a house. There are some kids in the house that need to clean their rooms. They have a lower probability of actually getting the room cleaned. And so this is the equivalent of the make pizza function. So just like we had a customer before, we now have a kid. We're passing in a string, but you'll notice that we're not passing in a callback. However, we are now returning a new promise. And this new promise takes a function. So what generically is this function? It's a callback. Okay? And the function, this callback function itself needs a resolve and a reject.
Those are defined in JavaScript,
the promise itself is, yes. So this new promise, this new promise is defined in JavaScript, and it expects two different things, the first of which will be your resolve function, and the second of which will be your reject. Yeah, you don't have to. You could call them something else. You could if you wanted to. I would be hesitant to, just because of convention, and people will understand your code better picking it up. Again, set timeout for simulation purposes only, lag for simulation purposes only. So just like before, we've got basically our generator here to determine whether it's going to be a successful room cleaning or not, our Boolean value for whether it was or not. We're going to log that out from within our promise. And then we've still got our if statement, but this time, instead of passing back an object with a status and a message, we're going to pass back either a resolve or a reject, and we're just going to pass it a message in this case. You could pass it an object, and you could also pass it for the reject a error if you want it to. So, any questions, comments, observations about this in comparison to the callback version?
Should reject be declared explicitly? I mean, if we don't declare it, will it return like null value or something?
We will play with that once we've got code running. Great question. Anybody else?
What was the question? Oh, the question was, if we're not explicitly define reject value, what will happen? Like, will it return null value, like nothing, or there's like a defined error? Yeah.
Okay.
So
So
Okay.
right now, as it is, reject is undefined, if you will, or it's not?
I don't know. It is defined. Like reject will pass in failure plus
It
KID.
means is what happens if you don't reject.
Yeah. If there's no else,
Yep.
like if there's only if statement, like
Oh.
if the function was successful, we return resolve with some values.
Yeah.
But if we like not planning that it will ever fail, like we
Right.
don't declare else,
Yeah.
what will happen if it eventually fails? So,
Okay.
but yeah.
Yeah, the promise will just never be resolved.
So let's go ahead and run this once. So this is the equivalent of our single table. So we're going to call clean room. We call it with Alice. And we're going to assign it to the variable Alice cleans room. And that is, in and of itself, a promise object at that point. We then have to pass it a then. We have to attach a then to it in some form or fashion. And just like before, we have a resolve and a reject. We need to tell it what to do if it resolved, and we need to tell it what to do if it rejected. So these are the callback functions that get passed in to the other callback function. These are explicitly in the then, and there is a comma there, which has caught me up more times than I care to admit. Yep. I'm actually going to go ahead. Yeah, so that's right up here. And so we're returning this promise with a resolve and a reject. This is the function that we're passing into resolve, and this is the function that we're passing into reject. Right? Any questions? Okay. I'm going to go ahead and save that. We're going to run that puppy. I think we're going to run that puppy. There we go. How did... My console log did not like... That's an interesting console log right there. Not sure why that's formatted quite like that, but okay, whatever. So we get the Alice cleaned her room, this one right here from within our promise object. And then we get the result down here for success, Alice, good job. Okay. You'll notice the success part is coming from up here. So we've added the success result to our good job. Does that make sense?
So you call clean room, you pass in only Alice.
Correct.
And that does whatever it does. And then when it comes back, it's going
So,
to do Alice cleans the room.
so at the point that I call this, it's creating that promise object.
Yeah.
And then this then right here is what handles the functions.
Okay, because
Correct. Okay. Now, real quick, I'm going to go ahead and comment that out, and I'm going to comment that out, and I'm going to kill you. So, and I'm actually going to bump our probability down. Okay, so the probability that Alice cleans her room is pretty bloody slim right now. And we are not even attempting to handle reject, and we're not trying to handle an on reject at all. So if I run you now, so up here in our promise code, Alice, in fact, failed to clean her room, but we don't do anything down here with the then. Does that answer your question? So let's log. This is my favorite console log. Nice and short and simple. You want to take a stab at what's going on?
I've been dealing with similar stuff, and in Node.js I was running on AWS Lambda on Node 8 runtime, and I tried to use asynchronous calls and everything. And I was just curious how I did it, because it works, but I wasn't sure how, and I wanted to compare. So you'll ask me that.
Okay, so we're not actually doing anything with the result at this point.
I was wondering if, when a promise is pending, you can console log it, and it'll tell you if it's pending. I was wondering if you could set up like a timeout to console log Alice clean room after like 3 seconds, so you can guarantee that you'd console log it after it's done and see if it's still pending. Or...
Oy vey. Out. And that was a fail. Alice. This room and 3 seconds. That was not 3 seconds. Oh, duh. Let's try that again.
So the promise never resolves.
Correct.
Nothing is returned.
Correct. Yeah, it's just left out there hanging. Yep.
Would that affect performance? I mean, is that going to slow anything down? Is it still waiting for something, or is it just dead?
I don't know.
Okay, I don't know in the browser, but in my work I do things like this, but in Node environment. And when I forgot to put that one, I always get this error that says unhandled rejection, unhandled promise, unhandled catch error. So basically every time that I see that the unhandled thing in Node, I just need to go and put the reject. But that's in Node.
Yeah.
Maybe the browser is being gracefully failing.
And I will actually demonstrate some of those error messages. Did you want to say something? Oh, okay.
I thought so like with promises and resolve, I thought it goes to the web API, and then the event loop just keeps listening for it.
It very well may. Yeah.
So it'll just end forever unless you tell it to do something.
I would not be surprised at all. No, and it's. I have to admit, one of the reasons I said let's try it is because the ESLints that I work with won't let me do this. Like, I literally cannot compile my code without it.
Just one more thing. The other day I was making a database, fake database for a company that we were creating a program. But this database I have to create 1 million users. So basically I have to, but I was creating those things just in the front end, just in a UI. So it has happened to me a couple of times when I have to do something very heavily that the backend is just taking forever because you need to be injecting record by record to the database, and it gives me a timeout in the front end. I remember that I had to go and tell it like, hold your horses, give me more time, because it's a million injections. So basically, maybe after a period of time, that it has, because that happened to me, because I was like, okay, just wait until the database gets populated, there is a million users. I don't know if any one of you have tried to populate a million users, but it takes forever, like 20 minutes. And so basically, what is going to happen, I'm pretty sure it's going to tell you like time out, and it's going to stop the whole thing.
It's good to know. How do you change the timeout on it?
I don't remember. I check the code.
Okay. Post it to the Meetup. I'm curious.
I'm gonna,
yeah.
When you assign clean room to Alice Clean's room becomes the promise object.
Correct.
And then, so once you've done that, then you have, I guess, access into the promise.
Yes.
You can get stuff out of that promise with .then and so on and so forth. Okay.
So I'm going to go ahead and put us back to fully functioning, properly written promise.
Are you getting resolve and result out of the promise?
So I am getting this console log out of the function, and then I'm getting either the resolve or the reject sent back. This is the result. Whatever is in between whatever we're passing, reject and resolve, are the result here or the error here.
So where does result and error and ER come from? Are they defined within JavaScript?
No, they're fairly standard conventions. Yeah.
Do promise objects have to have a name? Like, is you just something?
They do not need a name. Nope. Nope. And I think I have an example where I think I do, where I don't have names. But for reasons that you will see momentarily, this one does. Okay. So what happens if we access that variable again, that promise object again? So now I've got one Alice Clean's room where we've assigned the promise, and then I've got two times when I'm assigning a then to it. I also have tacked on a finally to this one. We'll come back to that momentarily. Anybody want to take a stab at what we will see consistently when we run this?
No, but you need to add reject to your function.
Did I not do that? Thank you. Nice catch. Nice catch.
I'm just going to say something, it's because I just checked the code really quick. I use the library that is called Axios, because that library has a method that time out.
Yes.
Put it a humongous amount.
Yes. Okay, that makes sense. And if you're doing API calls, Axios rocks.
Yeah.
Okay, anybody want to take a stab at what we're going to consistently see when we run this?
Pick me if nobody else does it.
You're it.
Yeah, oh yes. I'm saying that it's going to call the second .then block that it resolves.
The second one. So
That one, yeah.
it's going to call this reward or punish.
And not the first one.
Not the first one. Okay.
So
Anybody?
I'm going to say that it will do both of them.
Okay. Is there anything else that we might notice when we run this?
Well, yeah.
Finally.
We'll notice a finally. Anything else? Okay. Yep.
Interesting.
What did I do? This was working code like a few minutes ago. What did I do? Reject, then. What's that?
It's not like a line 45. The second Alice Clean's room.
It's not a function because it's trying to go into the first function.
Oh,
There's no the first resumption.
finally is not a thing in regular JavaScript. It's in
I literally used this an hour ago.
Right here, line 49. Try commenting. I mean, that is closed. I don't know.
Just trying to go into a...
Why? What the heck? I wonder if
We're using a different browser.
I am using a different browser. I would not have expected that to be the problem. Yeah, I uncommented all of
finally
that.
just barely came
I literally uncommented everything before I came over here and before I committed and ran it, and it all worked perfectly.
I wonder if you have to Well, the only thing that looks a little bit different to me is line 32 and line 45, they don't have the parentheses in the callback function because it's just a string.
Do you need to put a semicolon at the end?
Right about
Yeah, I've got
Last
the...
line.
line 49.
Oh, no. That would actually break it if I had a semicolon there.
That's what
What the heck did I do?
Try it in the other browser you were using.
Wait, why would that break it? Because you already had the semicolon with the final.
Yeah, I'm not sure why it would break it. Well, and I'm not going to spend a lot of time on that quite yet. We'll
You can go look up can I use for final.
yeah. You know, I was using it because I was getting security errors. It made me update Firefox Dev, and yep, I bet you that's it. That said, now I'm really curious. If I refresh you, let's uncomment you. Come on. Yep. Okay. So yeah, the browser I was using was not supporting finally, so we'll use Chrome for the rest of this then. Okay. So our first console log is Alice cleaned her room, true. So this is coming from within our promise. The second success that we're seeing is this console log right here with our good job. So this is our first then off of the Alice cleans room object. Our third one, Alice, great job, is our reward individual, which is one of the convenience functions. And then the result recorded in family journal is the convenience function from this log in family calendar. So we got the output from the promise. We also got the results for both of our thens, and we also got the result for our finally. So I'm going to run this a couple more times, and I'm going to point out that this is true, and we have success and success. And if I run it again, we get false and failure, failure. And if I run it again, we get true and success, success. Anybody noticing a pattern? True, success, success, success. We're only logging when it's resolved, and whatever our resolve is here, we get the same thing for both of these. This is set at 50-50 chance. So I would expect if they were coming back with two different results, we would have seen two different results by now. We're not getting two different results. Why are we not getting two different results? It's only one promise object. So even though we've got the two thens, Alice cleans room is a single promise. Yep. Yep. So if I do that and I get rid of our semicolon there, that's functionally, and so there we go.
That'd be like two instances of an object pointed at the same object.
Yes. Yep. Yep. Exactly. Yes. Yep. Yep. Any other questions, comments? Nope. Okay. So we're going to go ahead and add in a couple other kids, and you'll notice that they're pretty similar syntax. A couple of differences. So where before we had a then and we passed it two functions, separated by a comma. The first one is referred to as your onResolved. The second is your onRejected. You can instead do a then, pass it the onResolved function, and then a .catch and the onRejected function. So that syntax is identical to that syntax for all practical purposes.
I'm not familiar with the finally. What exactly is that doing? Is it just saying this is the last?
Yep. So whenever the then is resolved, regardless of whether it is successful or a failure, it will then do that finally thing. Correct. And I believe even if you throw an error, it will still do finally, I believe. Yeah. Yep.
Is there any benefit to doing it with the .then and .catch as opposed to doing it comma separated?
I would say it really depends on the code base you're inheriting and your team. Yep. I prefer the then catch, but most of my code is, yeah.
Is there any reason to not declare a promise as const? Because the first one you declare is let. And I'm kind of confused what the functional difference would be there, why you would ever declare.
That is a really good question. I don't know why I did let there. No, and I don't know why. I don't know why I did. I was bouncing back and forth between the three of them, so my best guess is I had done something in callback previously. That's my best guess. But there's no reason that should not be a const there.
Are they typically consts?
So consts are used when it's not going to change. Since you're
you know it's not going to change.
Yeah.
Okay.
You're not going to change the reference.
Okay. It depends on what you're coding. Okay.
And the big caveat there is be careful using const with objects, arrays, anything that is an aggregate, because it's a pointer. It's not actually to the parent. It doesn't lock down the contents of it.
Well, it's fine, you just have to know what you're
Yes,
doing.
and that's the caveat. Yes. Yep.
If later in code you actually change the clean room function, would that change the promise object or no?
So if it's a const, you'll actually get an error if you try to change it.
The clean room function, not the Alice clean room?
Alice clean room is set when you invoke the clean room function.
Yeah.
Okay, so it doesn't ever, it just runs the function once.
Correct. Yeah, this is the promise object when it's assigned to Alice cleans room. Right.
So you could think of that line then in a sense as instantiating the promise?
Yeah, absolutely. So we now have 3 kids. They're cleaning their rooms. And these are all going to run at the same time. They may not finish at the same time because, different lags for actually cleaning the rooms. But we're a family, and we want to make sure that we don't just punish the kids who don't clean their room, but we want to, and we want to use peer pressure because we're cool like that. So in addition to they're going to get punished or a good job, they're going to get grounded or a good job, attaboy, if they do their room, we're also going to do a different type of handling for their promises. So you'll notice that I'm just passing in those variables. So the promises themselves are already done up above. We're only doing the promise itself once. But we're going to look at the results of all of those promises, and we're going to use a similar syntax. So we've got a then if they all succeed, and we've got a catch if anybody fails. So I'm going to save that. I'm going to run that. And so Charlie cleaned his room, and Bobby cleaned his, and Alice cleaned hers. And so everybody gets to go out to the ice cream store and have fun. The next week, let's see if they were as good. They're really good. They really are. Uh-oh, there we go. And unfortunately, that doesn't demonstrate what I wanted to demonstrate, so we're going to do it again. Okay, there we go. So you'll notice, first off, that they're coming in out of order because we started them all at the same time, but they took different amounts of time to actually clean their rooms. When they all come back as a success, we don't get the family status until the last one comes back. But if there is a failure, we get notified of the failure almost instantly. Like it's queued up a whole lot earlier, right?
Is that just so the promise not all is just looking for, because it has to wait for everything to be resolved. But as soon
Correct.
as it's like an all or nothing.
Yep.
Right? So
Yep.
As soon as there's an error, it's going to throw the cat.
Exactly.
So all is like and Are there similar promise functions for like ors?
Yes. Yep.
And then also, where's that, the promise dot all, and so, you have to pass in the promises.
Correct.
It's not scope to this one sheet.
Correct. Correct. So real quick, I'm going to go ahead. I'm going to kill our catch on the promise all. So I still have catches on all of the individual kids. And I'm going to drop our probability down a fair bit. We're going to run this again. And this is that uncaught promise. So even though I caught the promises for each of the kids, so each one of them, I've got an on rejected for the first, then with Alice, I've got a punish for the second Alice, I've got a catch for Bobby, and I've got a catch for Charlie. Because I did not have a catch on this promise all, I still got my error when I had a failure. Another question? Nope. Okay. We're down to 7 minutes. Real quick, I'm going to comment all of you out so we don't obfuscate too much. And the latest, greatest is the async-await. So this actually uses a promise under the hood. So this Make Modern Pizza is kind of a mashup of the pizza example from the first Callback.js example, but it is promisified. So you'll notice that we've got our return new promise. We've got a resolve or reject. We're making our pizza. We're logging it out. We've got our if that returns a resolve or calls resolve, and we've got an else that calls a reject. So that should look pretty familiar. Any questions? I would hope not at this point. And this is really the only example that I've got for this one. You'll notice that it's the most abbreviated. A couple other things that you'll notice. In front of the function, we have the keyword async. If you do not have that async and you use an await later, you're going to get errors. The next thing you'll notice is that we do have the keyword await in front of our Make Modern Pizza down here. Does anybody want to take a stab at explaining what that's going to do? Does anybody else notice anything odd about the code? Something different? Try catch. So instead of having a different oops for each one of them, we're going to try to do all of them. And if any of them error out, we're just going to call our oops function there. Good. Any questions before I run it? Yep, basically. So we are using a promise under the hood here. We are using callbacks under the hood here. Okay. So save that, and we're going to run that. And we're going to wait for Alice's pizza, and we're going to wait for Bobby's pizza, and we're going to wait for Charlie's pizza. And yay, the table gets served. And I broke my sequential in trying to clean something up. Excellent. I see what I did. I did that again. This was my last minute change. And try that again. Okay. And apparently the odds are with us today because I am not joking. As I was working on this yesterday evening, Charlie's Pizza kept failing on me, even with the same probability. I don't know why. What's that? Yeah, I don't know. So this one is not an async-await. It's just a slightly different version, showing you the promise version of the pizza. Again, I could have if I wanted to, because all that we care about is this promise all. If I don't want to log these out, I could have just done the Make Modern Pizza Alice, Make Modern Pizza Bobby, Make Modern Pizza Charlie. But, and this is why I did this example this way, so if I log these out, so I'm not awaiting. This is just the promise. I'm going to log out our variables here. We're going to wait for all of them to finish. If they all finish, we're going to log them out again, log out the variables again. Otherwise, we're going to catch it. And go ahead and run you. And you'll notice that we get those promise. Whoa, that's a new one. Oh, no, it was in Firefox, sorry. So we get the promise objects up here that are pending, and down here we get the resolved with the messages that come back with them. So when you log it out matters. Questions, comments? Do you feel enlightened or not?
So I know that async-await's newer.
Yep.
Is there some situations where you would just stick with promises and not do async-await, or is it just better if you do new stuff than just use async?
It's really going to depend on your purpose. So, for example, with the promise all, if I don't need to wait on each one of them, I just handle the promise and roll with it. If you have a need for synchronous-looking code, async-await rocks.
So could you use async-await by default if you wanted to? Or is it sometimes is it overkill, or is it
yeah, sometimes it is definitely overkill.
Okay.
Yeah, it's good to keep in mind that async-await is syntactical sugar on top of promises. So when you write a bunch of await statements, they're basically nested promises.
Okay.
So, I mean, it looks good for the code, but it'll add a lot of complexity to your code potentially if you're using it and you don't.
It's going to go back to what are you coding?
Yes.
Yeah.
Okay.
Yep.
So
100%.
sometimes even a callback might be suffice.
Yeah.
Yeah.
In cases where callbacks
Yeah.
work.
Yeah.
Or is it more likely now that you're going to, I'm just going to write a promise instead?
So you're still going to use callbacks. We're still using callbacks in the promise and the async-await. I haven't used callbacks for asynchronous JavaScript in a while. Have y'all out of curiosity?
Yeah. Callbacks
Yeah.
and some things. I'm trying to think of the exact
Yeah.
situation.
Yeah.
Yeah, definitely talking to libraries all the time.
So there are still occasions. With the promise, when you assign the promise to a variable, it is the promise object itself. And so if you try to do something with that variable before it's resolved, you're dealing with the promise object, not the resolution of it. Right? With await, you are only assigning the value of the return from the promise. The resolution.
Yeah, so you're taking that resolved value that would normally be inside the then function, and you're assigning it to that variable on the outside. So it's making it a lot easier for you for how you interact with the code.
And I'll highlight that again. Actually, this is the example. Sorry. So the difference is actually this last example here. So these three outputs here, these three promises pending, those are what happen if you assign the promise to a variable before it's resolved. And these are the results if you assign it after it's already resolved. And so if you do an await with the assignment, by definition, you are always going to have a resolution.
So it'll be that string.
Yes. Yes. Thank you. Did that make sense to everybody? Help clarify? Yes. Yes, you do. Yep. And if you look at our time, so this is the one where we're doing the pizza all, so we're not doing an await here. And you'll notice that it took a little over 2 seconds. I'm going to go ahead and run it again. There we go. So a little over 2 seconds. Apparently my computer's slowing down. So if I run the await version up here, waiting on Alice's, waiting on Bobby's, waiting on Charlie's, a little over 6 seconds. Right? And they had to finish in order because of the await. So first one finish, second one finish. Yeah. Cool? Lively bunch tonight. Okay.